Dubai gets 94 millimeters of rain per year. To put that in perspective, London gets 600, New York gets 1,200. Even Los Angeles, a city famous for its droughts, gets 380 millimeters annually. But Dubai isn't a quiet desert outpost. It's a city of 3.5 million people, a global financial hub, home to one of the world's busiest airports, a place where hundreds of thousands of tons of food are consumed every year. Food that requires water to grow, water to process, water to transport. The United Arab Emirates produces less than 1% of its own food domestically. Almost everything, every vegetable, every grain of rice, every liter of milk, is imported. Because you can't grow food without water, and the UAE has almost none. The broader region is in a structural water crisis that has no easy solution. The Arabian Peninsula sits above aquifers that took tens of thousands of years to fill, and that are now being depleted in decades. Groundwater that cannot be replenished on any timescale that matters to human civilization. Desalination. Turning seawater into drinking water covers about 40% of the UAE's needs. But desalination is extraordinarily expensive, extraordinarily energy-intensive, and does nothing for agriculture. So the question that UAE engineers and government planners have been asking for 20 years is simple. If we can't find water underground, and we can't afford to make enough from the sea, can we pull it from the sky? Here is something that almost nobody outside of atmospheric science knows. At any given moment, there is more fresh water floating above the Arabian Peninsula, locked inside clouds and water vapor, than flows through the entire Colorado River in a year. It's just up there, unreachable, moving across the sky and evaporating before it ever hits the ground. For decades, meteorologists knew this. They could measure it. They could track it. They could watch billions of liters of potential fresh water drift across their radar screens and disappear over the horizon. But they couldn't touch it. So here's the question that drives this entire video. The UAE has been running a cloud seeding program since 2001. They've spent over $20 million just on research and development alone, not counting operational costs. They've conducted over 300 seeding flights in a single year. 23 years of trying to make it rain in one of the driest places on Earth. Is it actually working? And if the answer is yes, why isn't every water-stressed country on the planet doing exactly the same thing? The answer, it turns out, comes down to a technology that didn't exist 5 years ago. The UAE's cloud seeding program didn't start with drones and artificial intelligence. It started with propeller planes, silver iodide flares, and a lot of educated guessing. The original method was straightforward. Meteorologists would identify a cloud formation that looked promising, fly a plane through it, and release silver iodide particles to encourage precipitation. Then, they'd wait. The problem was that looking promising is not a scientific measurement. Cloud seeding has an attribution problem that plagued it for decades. When it rained after a seeding operation, was that because of the seeding? Or would it have rained anyway? And when it didn't rain, was the seeding wrong? Or was the cloud formation simply not ready? To successfully trigger precipitation from a cloud, you need approximately a dozen atmospheric variables to align within specific ranges simultaneously. Miss any one of them, and the seeding fails completely. And those variables change, minute by minute, as the cloud evolves. In 2001, when the UAE launched its program, the atmospheric data available to make that decision came from a handful of ground stations and daily weather balloon releases, useful, but nowhere near precise enough to reliably hit that narrow window of opportunity. This is exactly what changed. Between 2020 and 2024, the UAE made a series of investments that fundamentally transformed what their cloud seeding program could do. First, a network of advanced Doppler radar stations across the country, providing real-time three-dimensional mapping of cloud structure and moisture content. Second, integration with NASA and ESA satellite feeds updated every 10 minutes, giving meteorologists a continuous view of cloud formation patterns across a 2,000-kilometer radius. Third, and most importantly, an AI system developed in partnership with the University of Reading in the UK, trained on 23 years of UAE atmospheric data, capable of predicting the optimal seeding window for any given cloud formation with a precision that no human meteorologist could match. The AI doesn't just tell operators when to seed, it calculates which specific altitude to target, what concentration of seeding material to use, and, crucially, what the expected precipitation outcome will be versus the baseline of no seeding. That last part is what solved the attribution problem. For the first time in the history of cloud seeding, the UAE could look at a rainfall event and say, with statistical confidence, that rain happened because we made it happen. And it was X% more than would have fallen naturally. The result was not incremental. It was a step change. UAE cloud seeding operations enhanced precipitation events by between 18% and 35% above baseline in controlled trials, numbers that, for a country receiving 94 millimeters of rain per year, represent a genuinely meaningful increase in available fresh water. When something works, other people notice. And when it works in a region where water is a matter of national survival, the effects spread fast. Let's trace the chain. Effect 1. The technology arms race. Saudi Arabia watched the UAE's AI-enhanced results and launched its own national cloud seeding program in 2022, targeting the Asir region in the southwest, where orographic clouds that form when moist air hits a mountain range, are most common and most seedable. Oman followed. Qatar formalized its program. Even Kuwait, with an almost flat landscape that makes cloud seeding technically difficult, began investing in atmospheric research. The technology being deployed in 2025 and 2026 looks nothing like the propeller planes of 2001. The UAE now operates cloud seeding drones, unmanned aerial vehicles that can fly longer missions, reach higher altitudes, and respond to AI targeting instructions in real time without a pilot making judgment calls. A new generation of seeding flares using nano-engineered particles, smaller and more uniformly sized than traditional silver iodide, dramatically increases the number of condensation nuclei per gram of material, making each seeding run more efficient. One UAE-based company, in the span of 18 months, grew from 19 employees to over 120, almost entirely to meet demand from Gulf governments for cloud seeding technology and expertise. This is no longer a research program. This is an industry. Effect 2. When it goes wrong. In April of 2024, Dubai experienced the heaviest rainfall in 75 years. 16 months of average precipitation fell in under 24 hours. The city's drainage infrastructure, designed for a desert, not a monsoon, was completely overwhelmed. Within hours, the question spread across every platform simultaneously. Did the UAE's cloud seeding program cause this? The UAE government said no. Most atmospheric scientists agreed that the storm system responsible was a large-scale, low-pressure event driven by regional climate patterns, not a local seeding operation. But the episode revealed something important that nobody had seriously planned for. Cloud seeding, when effective, doesn't produce a precise, controlled amount of rain. It shifts probabilities. It encourages precipitation from cloud systems that are already primed for it. In a normal cloud formation, that means a modest enhancement. But in an already saturated large-scale storm system, the same seeding could theoretically push a heavy rain event into an extreme one. The science on this is still actively debated, but the Dubai floods forced a question that the cloud seeding industry had been quietly avoiding. At what scale does weather enhancement become weather risk? Effect 3. The sovereignty problem. Here is the geopolitical dimension that no government wants to discuss publicly. Clouds move. Wind does not respect national boundaries. When the UAE seeds a cloud system forming over the Gulf, the same system may have been expected to produce natural rainfall downwind over Oman, over southern Iran, over parts of Pakistan. If cloud seeding intercepts moisture that would have continued downwind and fallen naturally somewhere else, is that legal? Is that an act of aggression? Is it even measurable? The 1978 Environmental Modification Convention prohibits weather warfare, but defines harm thresholds so vaguely that a Gulf cloud seeding program operating 300 flights per year could argue indefinitely that it falls below them. No international court has ever ruled on a cloud seeding sovereignty dispute. No framework exists to adjudicate one, and yet the flights continue. Every week, year-round. Effect 4. The copycat effect beyond the Gulf. The success of UAE's AI-enhanced program didn't just inspire Gulf neighbors. It became a proof of concept that water-stressed governments on every continent are now studying carefully. India has been running cloud seeding trials over Maharashtra and Karnataka, 2 states facing chronic drought, with results that government scientists describe as promising but requiring more data. Morocco launched an expanded cloud seeding program targeting the Atlas Mountains, where orographic conditions are ideal and where declining snowpack is threatening freshwater supply for millions of people downstream. In the United States, the Bureau of Reclamation formalized cloud seeding as a core climate adaptation strategy in 2025, with programs running over the Sierra Nevada and Colorado Rockies specifically to enhance snowpack, the natural reservoir that feeds rivers across 7 western states. And in every one of these programs, the same technology that transformed the UAE's results is being adopted. AI-powered atmospheric targeting that turns cloud seeding from an educated guess into a data-driven intervention. So let's return to the question we started with. The UAE has spent over $20 million on cloud seeding research and development. They've conducted hundreds of flights. They've built one of the most sophisticated atmospheric monitoring networks in the world. Is it working? The honest answer is yes, with conditions. The AI-enhanced cloud seeding operations show statistically significant precipitation enhancement in controlled trials, between 18% and 35% above baseline under the right atmospheric conditions. For a country that gets 94 millimeters of rain per year, that's not nothing. At scale across the country, across a full year, that represents hundreds of millions of liters of additional fresh water. That is real. It is measurable. It matters. But here is the conclusion that surprised me most when I went through the research. Cloud seeding, even when it works perfectly, is not a solution to water scarcity. The UAE knows this. The scientists running the program know this. The government officials funding it know this. What cloud seeding actually is, what the UAE has spent 20 years and tens of millions of dollars figuring out, is a way to make the most of what you already have. A cloud passing over the UAE already contains fresh water. Without seeding, 100% of that moisture continues moving and evaporates somewhere over the ocean. With AI-guided seeding under the right conditions, you capture 18% to 35% more of it than you would have otherwise. You are not creating water, you are recovering water that was always there, water that the atmosphere was going to waste. And that reframing changes the entire moral and political calculus around weather modification. This isn't about playing God with the atmosphere. It's not about countries stealing each other's rain. Although those risks are real and deserves serious governance attention. At its most fundamental level, what the UAE has built is an efficiency system for the water cycle, a technology that captures a larger fraction of the planet's existing fresh water before it escapes back into the atmosphere unused. In a world where 2/3 of the global population will face water stress by 2030, recovering water that was always there but previously unreachable is not a marginal improvement. It might be one of the most important technologies of the next 50 years. The surprising part is not that it works. The surprising part is that we spent 80 years treating it as science fiction. Next week, we're covering the most politically explosive story in weather modification history. Iran accused Israel of stealing its rain. And when we looked at the atmospheric data, the picture got very complicated very fast. Subscribe so you don't miss it. And if you want to go deeper on cloud seeding technology right now, the video on China's 35,000 weather engineers is linked on screen.